Hey there! Imagine a story so big and amazing that it stretches across the entire universe. Today, we are going on an incredible journey through space and time in the universe unveiled, a journey through 5 eras. We start at the very beginning, the moment the universe was born in a colossal explosion called the Big Bang. Around 13.8 billion years ago, an incredible event occurred. In an infinite brief moment, the singularity underwent a mind-boggling transformation. It rapidly expanded, giving birth to the universe we inhabit today. This monumental event is what we commonly refer to as the Big Bang. Immediately after the Big Bang, the universe was unimaginably hot and dense. It was a hot mixture of fundamental particles such as quarks and leptons and intense radiation. However, as the universe continued to expand, it also began to cool down. The cooling allowed for a crucial transition, the formation of the first atom. Around 380,000 years after the Big Bang, the universe cooled enough for electrons to combine with protons and neutrons, forming the very first hydrogen and helium atoms. Gravity, a fundamental force of nature, played a crucial role in shaping the universe's structure. Tiny fluctuations in the density of matter, imprinted during the early stages, acted as seeds for the growth of cosmic structures. Under the influence of gravity, matter started to clump together, forming galaxies, galaxy clusters, and vast cosmic filaments. Over the years, scientists have gathered a wealth of observational evidence supporting the Big Bang theory. One compelling piece of evidence is the redshift observed in light from distant galaxies. This redshift indicates that galaxies are moving away from us, suggesting that the universe is continuously expanding. Another critical piece of evidence is the cosmic microwave background radiation, often called the afterglow of the Big Bang. It is the relic radiation left over from the hot, early phase of the universe. Through careful measurements, scientists have captured this radiation, providing us with a snapshot of the universe when it was just 380,000 years old. When the Big Bang theory has made extraordinary strides in explaining the origins and evolution of our universe, there are still profound mysteries that remain unsolved. One of the most interesting questions is what caused the singularity and initiated the Big Bang itself. Scientists are actively exploring ideas like quantum gravity and inflationary cosmology to shed light on these enigmas. Furthermore, the Big Bang theory does not provide insight into what might have existed before the singularity or how the singularity came into existence. These profound questions continue to challenge the boundaries of our current understanding, pushing scientists to explore new frontiers and develop even more comprehensive theories. As we dive deeper into the awe-inspiring concepts of the Big Bang theory, we can't help but marvel at the immense scale and complexity of our universe. From the tiniest subatomic particles to the vast expanse of galaxies, the story of our universe's birth and evolution is a testament to the wonders of science and human curiosity. The Big Bang theory has not only provided us with a framework for understanding the history of our universe, but has also paved the way for groundbreaking discoveries and advancements in cosmology. Through sophisticated telescopes and space missions, we continue to explore distant galaxies, study cosmic microwave background radiation, and investigate the eccentric web of cosmic structures. Moreover, the Big Bang theory has deepened our understanding of the interconnectedness of all things. It reveals that the atoms in our bodies, the stars, and the galaxies millions of light years away are all part of this grand cosmic event that originated from a single event, the Big Bang. The Primordial Era refers to the dawn of time mere moments after the Big Bang. Imagine a time when the universe was unimaginably hot, dense, and bursting with energy. The fundamental forces that govern our universe today, gravity, electromagnetism, these strong and weak nuclear forces, were all unified into one. At this primal stage, the universe was like a cosmic vessel simmering with particles and radiation. But as the universe expanded and cooled, incredible transformations took place. Matter and antimatter were constantly being created and annihilated, a delicate dance occurring in the primordial soup. But then, something extraordinary happened. A tiny excess of matter survived and went on to create everything we see today. With the expansion and cooling of the universe, protons, neutrons, and electrons emerged. As the universe evolved, these particles played a crucial role in shaping its destiny. One of the most compelling pieces of evidence supporting the primordial era is the cosmic microwave background radiation. This faint echo originated from just 380,000 years after the Big Bang blankets the entire universe. It provides us with a glimpse into the early structure of the cosmos. Scientists have developed remarkable theories and conducted experiments to study this enigmatic era. They have explored concepts like cosmic inflation, the rapid expansion of the universe, which helps explain its uniformity. By analyzing the patterns in the cosmic microwave background, they have unlocked valuable insights into the birth of galaxies and the formation of cosmic structures. As the primordial era unfolded, it transitioned into the inflationary era, the radiation era, and the matter era. These eras marked significant milestones leading to the formation of galaxies, stars, and ultimately life itself. Reflecting on primordial era fills us with awe and wonder, for it reveals the immense power and intricate beauty of our universe. From a searing hot, unified state to the vast expanse of galaxies we observe today, it's a captivating journey of cosmic evolution. Scientists use a range of techniques to study the primordial era. They study the cosmic microwave background radiation using specialized telescopes and satellites, carefully analyzing its properties and patterns. They also conduct experiments in particle accelerators, recreating the extreme conditions of the early universe to learn more about its fundamental particles and their interactions. The primordial era continues to be a subject of intense scientific investigation. It fuels our curiosity and drives us to explore further. As we uncover more about this fascinating period, we gain a deeper understanding of our place in the cosmos. The Stelliferous Era is an extraordinary time when galaxies light up like grand fireworks displays. Gigantic clouds of gas and dust come together, almost like a big celestial hug, giving birth to new stars. It's like a magical dance of creation happening right before our eyes. As stars come to life, something amazing happens deep inside their cores. At their very hearts, hydrogen atoms join together in a cosmic fusion party, releasing energy in the form of light and heat. These baby stars start shining and glowing with all their might. Stars come in all sorts of shapes, sizes, and colors, each one with its own unique story to tell. Big blazing blue stars are like cosmic giants, burning up their fuel quickly but living fast and bright. On the other hand, tiny, cool red dwarf stars might not shine as bright, but they can last for billions of years. The Stelliferous Era is also a time of cosmic teamwork. Galaxies, which are vast families of stars, twirl around in cosmic dance, sometimes even merging together to create bigger and more spectacular galaxies. When galaxies merge, it's like watching a cosmic collision of colors and lights. And at the center of some galaxies, there are these mysterious, supermassive black holes pulling everything around them with their super strong gravity. Throughout billions of years, the universe has been going through an incredible transformation during the Stelliferous Era. Galaxies have grown and changed, stars have been born and passed away, and so many beautiful cosmic events have shaped the universe we know today. Isn't it just mind-blowing? We are lucky to live in a time when stars light up the night sky and fill our universe with such beauty. When we look up at the stars, we are seeing the legacy of countless stars that lived and died long, long ago. But remember, the Stelliferous Era is just one act in the grand cosmic play. As stars eventually use up their fuel, the universe will gracefully move on to other eras, unfolding new chapters in its cosmic tale. The Degenerate Era is a time that occurs trillions of years from now, long after our Sun and other stars have lived their lives to the fullest. You see, stars are like cosmic engines burning hydrogen fuel to shine brightly. But like all engines, they eventually run out of fuel. As stars run out of fuel, they undergo a spectacular transformation. Smaller stars, like our Sun, will become something called a white dwarf. It's like a dense stellar ember packed with all the stars' mass but squeezed into a tiny space. These white dwarfs will cool down slowly over countless ages, eventually becoming what astronomers call black dwarfs. Imagine them as dark, cold remnants of stars that once twinkled brightly in the night sky. Now, for the bigger stars, things get even more exciting. They go through a dramatic collapse, forming either neutron stars or black holes. Neutron stars are incredibly dense and tiny, with the mass of a star crammed into a ball the size of a city. But black holes are the real cosmic mysteries. They have super strong gravity, pulling everything around them, even light. I have explained them in detail in my black hole video. As the Degenerate Era unfolds, these stellar remnants like white dwarfs, neutron stars, and black holes will roam through space. They might occasionally interact with each other like a celestial game of tag influenced by gravity's invisible force. And guess what? Over unimaginably long time scales, these remnants will collide and merge, forming even more massive black holes. It's like a grand cosmic dance, reshaping the universe in ways we can only imagine. As time passes, these stellar remnants will be all that's left. The last stars will fade away, and the universe will grow darker and colder. It's like a cosmic twilight where the era of starlight gradually comes to an end. Isn't it mind blowing? We are talking about a future so far away that it's hard to imagine. The universe will evolve in ways beyond our current understanding, taking on a whole new character. Now, let's remember, the Degenerate Era is still a theoretical concept. It's like a cosmic vision that scientists have pieced together using our current knowledge of the universe. As we explore the wonders of the cosmos, we are also unraveling the mysteries of its future. Thinking about the Degenerate Era reminds us of the sheer vastness of the universe and the epic timescales of its evolution. We are just a small part of this grand cosmic story. The black hole era is a hypothetical stage that could happen trillions of years from now. Imagine a time when black holes becomes the most influential objects in the cosmos. The black holes are like gravitational giants, tugging and shaping the destiny of the universe like celestial sculptures. During this era, black holes will grow even bigger and more massive. How? By merging with other black holes, and also by devouring matter around them like hungry cosmic monsters. These mergers and feasts will transform the landscape of the universe, creating supermassive black holes that dominate the cosmic stage. As black holes feast on nearby gas and stars, they create swelling disks of superheated matter called accretion disks. Picture a brilliant cosmic feast with black holes as the ravenous eaters. In the black hole era, black holes will have much incredible gravitational pull that will shape everything around them. They will create invisible webs of gravitational fields, bending the paths of stars and even bending light itself. It's like they are leaving their cosmic footprints on the fabric of space-time. As the black hole era progresses, something fascinating happens to our universe. It expands and cools down. Imagine the universe losing its heat, like a cosmic breeze sweeping through space. This cooling down is a gradual process that affects everything in the cosmos. With black holes dominating the cosmic landscape, other structures like galaxies and stars may become less relevant. The universe might be a vast expanse of darkness, with black holes ruling the celestial realm. Some scientists call this period the Dark Era, and it's an awe-inspiring thought. Imagine a universe mostly cloaked in darkness, where black holes are the cosmic kings and queens. The Dark Era is a speculative time that might occur trillions to quintillions of years from now. Picture a time when all the black holes in the universe have disappeared, leaving behind only faint traces of their existence. Black holes are like cosmic vacuum cleaners, gobbling up matter around them. But did you know they also emit something called Hawking radiation? It's like a cosmic whisper, tiny particles that escape from the black holes, causing them to lose mass over time. As the black holes slowly evaporate away, the universe becomes a vast expanse of darkness. It's like an endless canvas of deep space, where there are hardly any sources of light left. During the Dark Era, a mysterious force called dark energy continues to shape the universe. It's like an invisible breeze pushing galaxies further apart. This gentle push contributes to the cooling of the universe over time. To know more about dark energy, check out my dark energy video. With no new stars forming, the universe enters a cosmic twilight. Stellar nucleosynthesis, the process that creates new elements in stars, gradually fades away. The universe will mainly consist of hydrogen, helium, and a few other light elements. The dark era is so far into the future that it goes beyond our current understanding of physics. Scientists have proposed fascinating theories like vacuum decay or the expansion of space itself to imagine what could happen during this time. Now, here is a thought that blows the mind. Over trillions to quintillions of years, even the protons, the tiny particles that make up atoms, may decay. It's like matter itself, the building blocks of everything, slowly dissolving into nothingness. The Dark Era takes us on an incredible journey into the unimaginably distant future, a time of cosmic changes we can hardly fathom. That's it, the possible life of universe based on our current scientific understanding. You might be wondering why I didn't specify its end. Well, there are many theories about the end of universe, like big freeze or heat death, big rip, big crunch, etc. If you want a video on those theories, then comment me down below. See you in the next one.